Ladies and gentlemen, welcome back to Mr. Lee Physics class. Today, we will learn about Wheatstone bridge. Ladies and gentlemen, the aim for this study is to study the principle and use of the Wheatstone bridge. Lesson objective in this lesson, students learn the principle and use of the Wheatstone bridge. Objective 2, the principle and use of the meter bridge. Objective 3, the use of shunt. And objective 4, and the use of multiplier. Assume period knowledge. Students should be familiar with the equation V equal IR. That means that there is the Ohm's law. And students also should be familiar with the Kirchhoff's law, which Kirchhoff's first law and the second law. Ladies and gentlemen, let's look at the slide. The slide shows a multimeter. The multimeter is adjusted to the scale of the ohms. This means that this multimeter is ready to measure the resistance of a resistor. We switch on and touch the two terminals of the multimeter through the resistor. We found that the resistance shows that there is full scale of the reading. Ladies and gentlemen, is it the multimeter show the exact reading of the resistance? The answer is no. This maximum may be, because this maximum is the maximum reading that can shown by the multimeter. But what happens if the actual resistance of a resistor is higher than 10 ohm, maybe 100 ohm, 1000 ohm, and so on? So what we need to do today is we will modify the 10 ohm multimeter, maximum 10, yeah. So to make sure the resistance of a resistor, which is not in this range. Ladies and gentlemen, in this lesson, you will learn the principle and the use of the Wheatstone bridge. The principle and the use of the meter bridge. The use of the shunt and the use of the multiplier. Let's observe the next slide. Ladies and gentlemen, the slide shows 4 resistors, which 2 of them are connected in series. 4 ohm are connected series with 4 ohm. 6 ohm and 2 ohm resistor are connected in series. So now, a battery with EMF 2 volt is supplied to the resistors. The diagram at the left side shows that the concept of the flow of the current. Now the current is flow. What happened once I connect the switch? We notice that the ammeter reading, which is maximum. This means that the current flow from point A to point B. Now, if this one 6 ohm, 2 ohm, 6 ohm, 2 ohm, What will happen if I connect the switch? Once the switch is connected, we notice that the electric potential at A and B actually are equal. The potential at point A and potential at point B are equal. When both sides are equal, this means that from one end to another end of the ammeter are equal. Meanwhile, there will be no potential difference. If no potential difference, this means that show that there will be 0 volt. Ladies and gentlemen, the connection of the resistor just now can be shown by the diagram. Consider CA and AD. The resistor P and Q are connected in series, where R and S are connected in series. Okay. And then PQ are parallel with RS. PQ are parallel to RS. Now, the current flow through P and Q, consider is I1. The current flow through R and S, consider is I2. R is the unknown resistance. PQS, unknown resistant resistor. So we notice that PQS with the same color, right? So they have the same reading. So what is the resistance of the R? The principle, when the galvanometer is balanced, this means that no current flow between the point A and point B. Why? Because the potential difference, the potential of A equal to the potential of B. That means none of the potential difference occurs. 3, the same current I1 flow in the resistor of resistance P and Q. The same current of I2 flow in the resistor of resistance R and S. Why? Because PQ are in series. RS are in series. So potential difference VCA equal to V potential difference of CB. Okay, so CA equal to CB. So this means no potential difference. Another one should be VAD equal to BD. The potential difference across the point CA equal to the potential difference across the point CB. The potential difference across the point AD will be equal to the potential difference across the point BD, where I1 RP, I1 times with P, right? P resistance, I1 times P equal to I2 times with R. And this is first equation. I1 times with Q, IR. The resistance of Q is equal to I2 times with S. So once we solve it again, this means I1P over I1Q. I1P over I1Q will be equal to I2R over I2S. So at the end, we get that the resistance P over Q will be equal to R over S. P over Q will be equal to R over S. The ratio of PQ is equal to the ratio of RS. So we can find the R by using P over Q times with S. Okay. As a conclusion, we can say that the Wheatstone bridge circuit is shown as in the diagram, where it is formed by 4 resistors. 2 resistors, each 2 resistors are parallel. Sorry, each 2 resistors are connected in series. For example, P and Q are in series, R and S in series. But P, Q, both of them together are parallel to the resistor of RS. Next, when the Wheatstone bridge is balanced, this means that no current flow between A and B. No current flow means that the potential difference at point A is equal to the potential difference at point B. Voltage at point A equal to the voltage at point B. Next, electric potentials at A and B are same. We can determine all their relationship are resist. We use the resistance, the ratio of the resistance. Resistance of R over S equal to the resistance of P over the resistance of Q. So easiest, we said that resistance RP over RS equal to R over S equal to P over Q. Now, ladies and gentlemen, we observe the next diagram. For example, now we have 2 non-resistors. Another one is adjusted resistor. This means that the resistance can be changed. Example, rheostat and so on. R will be the unknown resistor. Okay. Now P over Q is equal to 1, right? If P over Q equal to 1, that means balance or not? No. That means that PQ, the current is flow. So that means that here got the potential difference. What I can do when I increase, okay, PQ, P over Q equal to 1, that means that the concept R over S will be equal to 1 as well. Once I adjust until I get the balance point of the 0 point of the galvanometer, that means that the current at A equal to the current at B. Potential difference of A equal to the potential difference of B. So this means that P over Q is 10 over 10, right? 1, right? That means that R over S must be equal to 1. So what will be the R? The R will be equal to 20 ohm. Okay, PQ is equal to 1. That means times with the S. So by using the formula, P over Q equal to R over S, we get that the resistance, the reading of the resistance, the R will be equal to 20 ohm. Student, let's observe the diagram again. Now 100 over 10. If P over Q is equal to 10, that means that we adjust until I get the reading of 0. The resistance show that is 100, right? That means that P over Q is equal to 10. PQ, by using PQ equal to P over Q equal to R over S. That means that we use PQ over P over Q equal to R over S. By substitute P equal to 100 ohm, Q equal to 10 ohm, S equal to 100 ohm, then we get that the R will be 1000 ohm. Look at here, P is 10 times of Q. This means that R should be 10 times of S. So 100 times 10, 1000 ohm. Now we go to the next slide. Now P over Q is equal to 1 over 10. No matter how, the P is smaller, right? If P is smaller, this means that once I get the balance point by using PQ equal to R over S. P is 10 times smaller than Q. R should be 10 times smaller than S. So this one 20 ohm, smaller, 10 times smaller, R should be 2. By using the formula, we get that the resistance of R will be equal to 2 ohm. As a result, as a summary, we can say that the Wheatstone bridge can be used to determine the resistance of a resistor. For a resistor of large resistance, the value of the ratio PQ, P over Q, is fixed at a large value, more than 1. For a resistor of low resistance, the value of the ratio P over Q is fixed at a small value. That means less than 0. Sorry, less than 1. Okay, PQ more than 1 or less than 1. Less than 1, 0 point something M. And now we observe the diagram. This meter bridge shows that a battery is connected to a switch, on-off switch. The switch is connected through a wire, a conducting, a resistant wire of 100 cm. At the same time, we connected, okay, to a wire with resistance, and also the other resistor. That means here we have 2 resistors. Okay, just now we have 4 resistor, right? So that means here R and S. Consider is the PRS, still the RS. Now the PQ, that means that at any point it will be PQ. First, we notice that here will be the wooden base. This structure almost equal to the potential meter. Okay, so now wire with unknown resistance, that means we want to find the resistor later, the resistance of the wire later. Here will be the copper strip used as a connector. Wooden base, that means that used as an insulator. Okay, and the uniform slide wire, that means that what is meant by uniform? Uniform of cross-sectional area. We use jockey. So this means that we connect the jockey in between the 2 resistors. This means RS, R and S. How about PQ? PQ on the wire in between AB. Now the circuit diagram will be like that. If we use the circuit diagram, that means that we will find out the length of the wire. Here is the A, here is the B. Now we notice that back to the circuit. So once I switch on, the current is flow. So what I need to do, I find out, observe the reading of the galvanometer. Okay, I move until I get a 0 point. 0 point somewhere here. Okay, this means that now what we can do, P over Q, the resistance of P over the resistance Q actually is equal to R over S. Okay. So in this diagram, in this experiment, what is or what are the precautions steps? First, the first precautions, all connection at the terminal must be properly fastened. If the connection loose, that means that less the cross-sectional area, the contact of the cross-sectional area reduced. So reason, loose connection cause the resistance in the circuit to be unsteady. Sometimes higher, sometimes lower. Once connected, well, this means connect with low resistance. Loose or lost connection, the resistance increase suddenly. Next, second precaution. The chosen standard resistor should be of resistance such that the balance point should be between 30 and 70 marks. This means that we try to have almost equal side. This means 30 to 70. That is the best region. Why? The degree of accuracy in the measurement of L1 and L2 are about the same. Okay. Next, repeat finding the balance point by interchanging the position of the standard resistor and the resistor of unknown resistance. We exchange the resistor and the wire. Reason, to eliminate an error due to different resistance at the NA and B. If both of them, let's say now I get the length A to the jockey and the jockey to B is 30, 70. Once I reverse the wire, once I reverse the resistor and the unknown resistant wire, the length of A to the jockey should be 70, and from jockey to point B should be 30. This means that 30, 70, for example, 30, 70 will be 70, 30. If both of them we get the portion, the portion are equal, this means that the error in the measurement considered is very, very low until almost none or no any random error, no error. Let's observe the next slide. When I connect, I find out the reading, the reading, you see, the reading cannot be obtained. Reason? Because here will not, and here do not have any resistor. Now I connect one resistor of S5 ohm. When I move it, we get that will be 80, 20. Where is not 30, 70, right? Or 70, 30, right? So what we need to do, we try to increase the resistance. When I increase, now I get that 44.5 and 50, 5.5. 55.5, yes. Okay. If I increase to 20 ohm, I found that the reading is 28.8 with 71.2. So most suitable is which one? So this means that if 10, we try to get both of them almost equal. The length L1 and L2 almost equal are the best. So as a result, we use the 10 ohm resistor. The 10 ohm resistor is the most suitable. This means that in this case, 5 ohm, 10 ohm, and 20 ohm can be used or not? Can. But the most suitable will be the resistor of 10 ohm. If we use 5 ohm, we still can get 80 and 20 cm. But maybe the possible error we calculate high, it will be higher than the possible error or the random error of the 10 ohm. Now, we notice that, sorry, the connection. We connect the R to one end, 10 ohm. So 10 ohm, just now 44/5, right? So once I found this one, it will be 56.3. So when I exchange it, now become 56.3. Just now, how much? Just now is 44.5. 44.5. Now 56.3. So almost equal, right? So what is the meaning? That means L1 is equal to 44.5 and 43.7, right? For the second ones we exchange. L2 will be 55.5 and 56.3. So average value of L1, that means 44.5 and 43.7. So we get that 44.1 cm. Okay. And 55.5 and 56.3. So I get L2, the length of 2 will be, the average is 55.6. That means I make sure 2 times that. So from here, average value, we get already, the S is equal to 10 ohm. The resistor is 10 ohm. So that means by using R over S is equal to L1 over L2. So still using the length 44.1 over 55.9 times with the S10, we get that the resistance of the wire will be 7.89 ohm. Ladies and gentlemen, as a summary, the meter bridge is a form of Wheatstone bridge. When the meter bridge is balanced, what will happen? This means that R over S, the resistance of R over the resistance of S, equal to L1 over L2. Above, left over right, will be the bottom part, the wire, length of the left side over the length of the right side. And we have 3 precautions in the experiment. First, all connection at the terminal must be properly fastened. Reason? Because loose connection cause the resistance in the circuit to be unsteady. Precaution number 2, the chosen standard resistor should be of resistance such that the balance point should be in between 30 cm and 70 cm max. Okay, or 70, 30 cm. Reason, the degree of accuracy in the measurement of L1 and L2, the length 1 and the length 2 are about the same. 3, repeat finding the balance point by interchanging the position of the standard resistor and the resistor of unknown resistance. Reason, to eliminate an error due to the difference resistance at the ends A and B. Next, let's observe how to convert a milliammeter to ammeter. Milliammeter, that means that this one just can make sure until maximum 1 milliwatt. Sorry, 1 milliampere ammeter. Where the milliammeter with 170 ohms. With a wire connected to a resistor, which series to the milliammeter, we notice that the reading maximum reading shown. That means that out of the range are not suitable to measure the resistance, the current that flow through the circuit. So what we need to do, I use a copper wire with resistance. Okay, resistance, copper wire, I connect it. Point A to point B. That means that now the copper wire also with resistor. How to determine? First, connect it. We try to adjust the reading of the rheostat. Calculation, current in the meter I1 is 1 milliampere. The current that passed through is 1 milliampere only maximum. Okay, current in the shunt is I2. That means that it will be 0.999 ampere. Okay, so here this will be the shunt. Okay, so from here, potential difference across the shunt will be equal to the potential across the meter. Potential voltage across the shunt and potential across the milliammeter will be equal. How much are them? That is 2 volt. Okay, so that means I2 times R equal to I1's R1. I1, that means the maximum is 1 milliampere. 1 milliampere times with 170 ohm. The resistance of the milliammeter is the voltage passed through the milliammeter. The voltage passed through the milliammeter equal to the voltage passed through the shunt. Okay, why? Because as we know that the total current in is higher, right? So that means that we allow 1 ampere to pass through. The rest that will flow through the shunt. When it's flow through the shunt, that means that I total equal to I milliammeter plus with the I current of shunt. So from here, we get that the R resistance of the shunt should be 0.17 ohm. As a summary, a milliammeter is converted into an ammeter by connecting a shunt of low resistance in parallel to the meter. The potential difference across the shunt will be equal to the potential difference across the milliammeter. Ladies and gentlemen, let's look at another slide. Now we want to convert the same milliammeter into voltmeter. Just now into ammeter. If voltmeter, that means that we must reduce the voltage. So what we can do, maximum is 1 milliampere. That means that the V1 equal to how much? Should be 0.01 ampere times with 170 ohm. The potential difference is maximum allowed potential difference is 0.17. So what we need to do, we need to add a shunt which is in series to the Okay, this is the structure. Inside, there will be a resistor. So what we need to do, once there will be a resistor inside, so the calculation, this means that we add a resistor inside the shunt. Current I pass through, that will be R, 20 ohm of the resistance of the ammeter plus with the resistance of the shunt is equal to 20 watt. If we want to measure 20 watt, okay? So this means that at the end, by using the formula, we get that R equal to 1980 ohm. Ladies and gentlemen, as a conclusion, to convert a milliammeter to a voltmeter, a high resistance resistor, known as multiplier, is connected in series with the meter. Shunt is used to divide the current, but voltage, no, still the same. But for the resistor, known as the multiplier, is connected in series to the multimeter. Okay, ladies and gentlemen, that is the end of today's lesson. Later, I will post the question on the Telegram. So what I want you to do is, first, you try to solve the question for today's lesson. After that, you check the answer. The question and answer I will post on our Telegram groups. Ladies and gentlemen, here are the questions for today's lesson. Question 1, question 2, question 3, question 4, question 5, and question 6. Last, question 7. So, that's the end of our lesson. Thank you very much, and we continue again on next lesson. See you and enjoy the physics.